I'm Akash Das, welcoming you. Today we are going to learn about work and energy. First, we have to understand what is the meaning of work. Suppose there is an object. We apply force on the object. Object will displace in the direction of the applied force. If object displaces in the direction of the applied force, that is known as the work done. Okay. Now we can classify work in three parts. First one is positive work. Second one is zero to work, and next one is negative work. Now, what is the meaning of positive work? Suppose there is an object. If you apply force from that side and object will displace in direction of the applied force. Okay, it is called positive work done. Next one is negative work done. Sorry, zero to work done. Now, what is the meaning of zero work done? Suppose if you want to understand this, we're going to a small example. Okay, suppose you are going to visit Agra Taj Mahal and you like Taj Mahal very much. You want to take the Taj Mahal at your location. So you will start to push the Taj Mahal. It doesn't matter how much force is applied on Taj Mahal, it doesn't move. So that means if force is applied on object but object doesn't displace, it's called zero to work done. Okay. Next is negative work done. What is the meaning of negative work done? To understand this, we are going to take an hypothetical example. Okay. Suppose Vande Vande Bharat is coming. He was just front of the Vande Bharat and try to push the Vande Bharat. It doesn't matter how much force you are applying, but Vande Bharat never moves in the direction of the applied force. Okay, it always goes in the opposite direction of the applied force. Okay, it is the example of the negative work done. That means if force is applied on an object, but object doesn't displace on the applied force, but it does is displace opposite direction of the applied force. It's called negative work done. Clear? Never try to do this. I'm just giving an example. Is it clear now? Now, how to represent work done mathematically? We know work. We can say that work equal to product of force and displacement. Okay, we can write W equal to F into S. It's become the main formula. Now we know that force equal to mass into acceleration. Force equal to mass into acceleration due to gravity. Input value of F into equation 1 will get W equal to M into A into S, or we can write W equal to M into G into H. Why am I writing H? Because whenever an object moves linearly, this that condition acceleration will be A. But if only any object going upward or downward, it always be G or minus G. And what is the value of G? It's 9.8. per second square. Clear? Now, height is also a displacement. That's why I'm writing h instead of s here. Clear? It's become the second and third formula. Another formula is, to understand this, we have to take a small look on the trigonometric concept. Okay, so there is a triangle A, B, C. Now it's from an angle. Here is an angle. Here is an angle. Angle are represented by theta. What is the theta? Now each and every angle has its own name. It's sine theta, cos theta, tan theta. How to understand what is the meaning of sine theta, what is the meaning of cos theta, what is the meaning of tan theta? We have to use an formula. It's not formula, actually I'm wrong. We have to use a mnemonics. Okay, it's Pandit Badri Prasad Har Har Bole. What is this? Pandit Badri Prasad Har Har Bole. Perpendicular. It's perpendicular. It's hypotenuse and it's base. So we can say that ratio of perpendicular and hypotenuse is called sine theta. Ratio of base and hypotenuse is called cos theta, and perpendicular and base is called tan theta. This clear? I remember cos 90, its value is always 0. Now suppose there's a tree and you are climbing on a tree. Okay, I know that my drawing is very bad. I'm not Pablo Picasso. Just consider your mass is m, height of the plant is, let's consider h, acceleration due to gravity is g. Okay, so we can write w equal to m g h. This is the formula of the potential energy. Clear? Now we have to use the application of trigonometry. Suppose there is a coolie, okay, who carries heavy load on its head. That means angle must be 90 degree. Am I right? What will be the formula? It will be w equal to m g h. Just a minute. 90 f into s into cos theta. If suppose you are carrying a heavy load over your head, okay. Now tell me what will be the angle? It's 30 possible? No. 45 possible? No. 180? Never. What will be the angle? 90 degree. So it doesn't matter how much force is applying, how much you cover the displacement. Your angle is 90 degree, cos 90. That means your whole value becomes 0. You multiply something, with 0, answer will be always 0. That means work done is always 0. You are carrying a suitcase in your hand, your angle will be 0. Is it clear? Because you're carrying the suitcase at 90-degree angle. Clear now? And value of cos 90 degree is 0. I think it is clear. Now we are going to study about energy. What is energy? Ability to do work is called energy. That means we can say that work and energy are always equal. Clear? We can classify energy in many parts, but in this condition, we are just going to consider only two: its potential energy and its kinetic energy. I think you know that at your level, it is a very famous formula. That formula of kinetic energy is W equal to half mv square. Okay. Now we have to understand how we get this formula or how to derive this formula. Suppose we know that W equal to F into S. Am I right? Here's number one equation. We know that W equal to M into A is equal to, we know I think you studied formula in motion, that is V square equal to U square plus 2 AS. Can you recall? From this formula, can we find the value of S? We can write S equal to V square minus U square by 2A. Now we are going to put the value of F and S in equation 1. Okay, what we will get? What is the formula? W equal to F into S. We are going to put the values of F and S. What is the value of F? It's M into A. What is the value of S? V square minus U square by 2A. A will be cancelled out. Sorry. Okay. Suppose if initial velocity is 0, then we can write m into v square by 2, or you can say half mv square. It is called the formula of the kinetic energy. Now, what is the meaning of kinetic energy? Kinetic energy requires to um, stay in motion. Okay, and what is the potential energy? Potential energy requires to stay in rest. Is it clear? I hope it will help. My video will helps you to understand the concept. Okay. Now we are going to take an example how we apply the formula in numericals. Suppose there is a girl whose name is Tina. Okay, her weight is, let's consider 90 kg. Okay, she is at height of 90 meter. Okay, now we have to find her potential energy. How to find? We know that W equal to mgh. It is the formula of potential energy. Am I right? So always remember value of G is 9.8. How much? It's 9.8. Arey baba. 9.8 meter per second square. So we can write 90 into 9.8 into 90. Now you have to solve them. Yes, you have to solve them. We'll get the answer. It is 79380. Now tell me what is the unit of work done and energy? I already told you work and energy are always same because I will do work is called energy. So unit will be same. What is the unit? It's joule. J. Okay. I hope you can understand little bit. I think the concept is going to clear. All the best. Thank you.